Hello everyone, my name is Pudina Prankor. I'm a student of Dibrugarh University. In this video, I will explain what algorithms and flowcharts are and how they help us program logically. In this slide, let us discuss about why we should study algorithms and flowcharts. Before we start any code, it's very important to plan how our programs will work. That's where algorithms and flowcharts come in. They help us organize our thoughts and create better error-free programs. Some of the reasons are mentioned in the slide. They are: number one, plan the logic; number two, they help us analyze and design; and number three, to ensure our solution is clear and error-free. Now, let us discuss about planning the logic. We must first plan the logic. Algorithms help us write down the steps clearly so we understand exactly how programs will solve a problem. This makes our work more structured and easier to follow. Now, next point is to analyze and design. Here, algorithms and flowcharts help us analyze and design our programs. Flowcharts show us a visual representation of the process and how data flows, how decisions are made, how it makes it easier to identify mistakes or improvement before coding. The next point, clear and error-free. Finally, using algorithms and flowcharts, it ensures our solution is clear and error-free. When our logic is properly planned and designed, we reduce confusions and save time during debugging. So overall, we have studied that studying algorithms and flowcharts help us think logically, design better programs, and avoid errors, which are the key to becoming a good programmer. Now, let us understand what an algorithm actually is. Let's start with the definition. An algorithm is a step-by-step procedure or a set of rules designed to solve a specific problem. It's like giving the computer a clear list of instructions that it can follow to get a result. For analogy, to make it simple, think of an algorithm like a recipe to a dish. Just like recipes gives us clear steps to make a dish, an algorithm gives us steps to achieve a particular goal in programming. For example, the steps to make a cup of tea or the steps to find the largest of the two numbers in programming, for example in C. There are three main parts of an algorithm. They are the input, in which the data we provide to the algorithm is inserted. Number two, process, the steps or instructions executed to work on that data. And number three, the final result or solution we get at the end. So in short, an algorithm helps us solve problems logically and systematically, step by step, just like following a recipe to reach a final dish. In this slide, let's talk about the main characteristics that makes an algorithm good and reliable. The characteristics are finiteness. A good algorithm must always end after a finite number of steps. This means it shouldn't go on forever. It must stop once the problem is solved. Number two, definiteness. Each step in the algorithm must be clear and unambiguous. There should be no confusion about what to do in any step, and everything must be well defined. Number three, for input, an algorithm should have zero or more inputs, meaning it can take data or values to work with. For example, when finding the sum of two numbers, the numbers are inputs. And number four, output. A good algorithm must produce at least one output. The result or final answers we get after executing all the steps are the outputs. And for number five, effectiveness. Finally, the steps of all the algorithm should be simple, practical, and easy to perform. Each instruction must be basic enough that it can be carried out without needing any extras. So in short, a good algorithm should be finite, clear, take input and give output, and be effective. These characteristics ensure that our algorithm works correctly and efficiently. In this slide, we'll talk about an example algorithm to find the largest number. This example shows the steps to find the largest of two numbers, say A and B. Step 1. Start. We begin our algorithm with the start step. This simply indicates the beginning of our process. And for step 2, input A and B. In this step, we take two inputs, the number A and B, which we want to compare. And for step 3, comparison, now we compare both numbers. If A is greater than B, we print A as the largest, otherwise we print B is the largest. This step is the main logic of our algorithm. It decides which number is bigger. Step 4, stop. Finally, we stop the algorithm. This marks the end of the process after displaying the result. So so this simple algorithm helps us understand the structure, how we start, take inputs, processes the data, and end with the correct output. Now let's move on the topic of flowchart. Its definition: a flowchart is a graphical representation of an algorithm using symbols and arrows. It shows the flow of steps clearly from start to the end. Some of its advantages are: it is easier to understand. It helps us easily visualize the program logic. Number two, team discussion, usually for explaining ideas and planning with others. And number three, debug efficiently. Helps us helps us find and fix errors before coding. Flowcharts make our programs clear, organized, and easy to understand. That is it. In this slide, some of the common flowchart symbols are mentioned. The oval symbol. This symbol represents the beginning or end of a program. The rectangle symbol. It is used to show any process or action like calculations or instructions. The diamond symbol. This symbol is for decision making, like checking if a condition is true or false. And the parallelogram symbol. It is used for input and output operations, such as entering data or displaying results. And the arrows, flow of control, like arrows show the direction of flow of steps in the program. These symbols helps make flowcharts simple, clear, and easy to work with. In this slide, we'll discuss about example of a flowchart briefly. The start process begin with the start symbol indicating the start of a program. Input num1, the first number represented as num1 is entered. Input num2, the second number represented as num2 is entered. Decision: num1 greater than num2. A decision point checks if num1 is greater than num2. If true, the process moves to the next step where num1 will be displayed. If false, the process moves to display num2. The stop process ends with the stop symbol, signaling the conclusion of the program. Now let us also discuss about the advantages of using a flowchart. The flowchart are a better way of communicating the logic of a system, making it easier to understand. The flowcharts act as a guide for blueprint during program design. Flowcharts also help in debugging process. With the help of flowcharts, programs can be easily analyzed. They provide better documentation. Flowchart serves as a good proper document structure. Now, for conclusion, algorithms and flowcharts are the building blocks of programming logic. They help us organize our thoughts, detect errors early, and develop efficient programs. To remember, before writing code, design our logic with an algorithm and flowchart, with, which makes the whole process more easy and efficient. Uh, Thank you for listening. I hope this helped. you understand the fundamentals of algorithm and flow.